So hello guys, so definitely we'll talk about infrastructure, and as you can hear, like we've got an accent, so related to the talk this morning, so it will be good. And more precisely, during this presentation, we'll focus on how like functional requirements and so on will make evolve a simple infrastructure at start and to become like we are calling in state-of-the-art infrastructure nowadays. Because it's always more fun to know who will talk right now. So I'm Erwan Alliaume, as you said, CTO of OCTO Technology. We are a consulting company dealing with many things, DevOps, cloud, big data, delivery, but also methodology and so on. And we are very small and many technology lovers. So we are about 20 people in Sydney. That's it.
Yeah, and I'm Eric, senior consultant at OCTO Technology. I've been working there for about 10 years, mostly backend architecture, and I'm very interested into DevOps as well.
Yeah, and because we are dealing with a lot of technologies and so on, yeah, we try to hire like T-shaped guys, like we did present this morning. It's not always easy, but that's at least a lot of fun. So why do we want to talk about infrastructure? So because like infrastructure is everywhere, like infrastructure, if you read the dictionary, it will be something like a base, a foundation that will allow you to build like a kind of structure around that. If we are talking about IT, the structure will be projects, and you can't run any project if you don't have CPU, RAM, network, and this kind of stuff. Today we are not like infrastructure expert, like we are dealing with many technologies, but we will focus on that. And we will see that there is not only one type of infrastructure, even if the resources are the same. Like if we try to do an analogy, when you try to build a shed, a garage, a house, or a castle, you won't use the same kind of foundation. So it's exactly the same with IT systems. The second point, or maybe the more important, as we said before, and Cassette just described that as the complexity during the previous presentation. In every decision, architecture decision, and functional requirements, it will make evolve your infrastructure. So it's not a bad thing, you need to embrace it. But it's good to keep in mind that each time you need to add like something new, the infrastructure has to evolve a bit at the same time. And we will like illustrate that during the rest of the presentation. And with these requirements, infrastructure will evolve, so we said, but the cost of your solution and the skill needed to maintain this solution will evolve too. So for that, during this presentation, we will illustrate that with the story of Lisa. Lisa is a kind of developer. She's really good technically. She's not only doing the development, like she can also manage costs, she can like build teams and so on. So yeah, she's something like a T-shaped girl. And Lisa got an idea. So even if she's working in a top i6 company right now, she got an idea to build like a side project, and she wanted to start with that and to see what will happen with our project. And during this presentation, we'll focus on the team and the infrastructure she will need for that. So she doesn't have any precise target in mind. So her goal is more to live the journey and so on, more than to focus directly on some precise point or achievement she wants to do.
So first thing first, Lisa wants to socialize her idea to make it known and to publicize it. So to do that, she starts very simple by just building a landing page so that she can communicate about her idea. So to build this landing page, she simply buys one server somewhere on some hosting provider and a domain name. On her server, she chooses an OS. She installs the runtime to be able to run this landing page, and she installs a very simple database just to manage a very little bit of content and information. And she links this domain name to this new server. For now, she has everything on her laptop, and she deploys it from her laptop with a few SCP commands. If for some reason her server crashes, that's no big deal. She can just redeploy it very simply. And once her idea is a bit communicated, she she can start now actually building the product itself. So she will start simple. She's heard of lean startup methodology, so she'll start with a simple MVP just to assess that her product does get some traction, to validate a few hypotheses, and to get a few early adopters. So she writes some code. She also buys a mail server so that she can reach out to her early adopters, to her new users, with a professional touch, so that her email comes from her domain name and not from gmail.com or something. And she also starts to produce some actual content on the website. And there's also some user-generated content that starts to be populated into the database. So she puts in place a very simple backup component that will get a copy of her code, as well as a copy of the data on a daily basis, and a copy of the artifacts that are produced by her build. Same as before, if there's a crash, that's fine. She can redeploy from her laptop. She may lose up to 24 hours of data, but she's okay to cope with that because the early adopters anyway are used to dealing with beta version of application.
Yeah, so because she was in the room this morning, she saw that she heard that in 2008, if you are not using SSL, like you won't be credible and so on. So her next step was to be so she's still working on a side project and so on, but she wants to be described as more credible or a bit more serious around that. So she said, I can't forget security around that. So she tried to put in place like a small reverse proxy. So the main idea is to have the green lock in her browser when the user are reaching her application. And she also start to follow and understand the top 10 web security principle that we have been described just previously. And in her database, like she tried to start to do some hashing, at least on password. Like in worst case scenario, if somebody get the data, they won't be able to retrieve the password and so on. And so far, everything is going good. She doesn't have a lot of pressure. She start to get several users, but it's not so complicated at this stage. Until one day, what did happen? So she put something on production, and unfortunately, so it's manual process at this stage and so on. She haven't tested like everything, and there was an issue with the kind of memory issue in our application and so on. And the application started to generate a lot of logs, like so much logs like that during the night, the file system of the only server she got was totally saturated. So it was a big issue because like all the systems she was using previously, if we come back, it was only one server. So on the same system, she got the application, yes, but also the database and backups and so on. So it was really, really scary. So she succeeded to fix the problem. And in order to avoid this kind of problem in the future, she decided to isolate a bit the services. So at least next time it occurs, like we've got a bug in the web apps could crash, but the database will stay intact and so on. So now it's changing a bit the run. She has to take care about several servers instead one, but it's still a few of them, so it's not so complicated to manage.
And great news, so this application actually made the news, and Lisa is starting to get some more users and some more momentum with this application. And she realizes that she cannot afford for her application to have a tarnished image by some outage or unresponsive service. So she starts to think about scaling out and fault tolerance. First thing she does is adding a new reverse proxy sitting next to the first one, which is only here to take over in case the first one should fail. She also adds more computation capabilities by adding a few instances of the web application. So there's now 3 instances running concurrently, and they are all running all together, being load balanced by the reverse proxy. She adds a session store as well, so that the user session information are not stored on the server itself, on the web app server itself, but it's shared across all instances thanks to this session store. And in the situation when one of those servers would crash, then the user does not lose whatever was in his basket or his authentication information. And she also adds a new database. So whether it's active-active or active-passive, depending on her solution, doesn't really matter. The point is that it's fault tolerant. If one of them fails, the other one can also take over. And the application starts to work well. It's beginning successful. So there are more and more users who asks for more and more features. And she realizes that she cannot cope with all these changes requests by herself. And that's good for her. She starts to recruit. And she does so successfully thanks to the success of this application. And she realizes that, or the team altogether realize that it's not very convenient to share code the way they used to do it. So, So they put in place a source management system, whether it's Git, SVN, Mercurial, pick your own solution, but it's most likely going to be Git, so that they can contribute easily to the same code base. They can submit pull requests, merge requests, review the code done by others, whether it's pre or post commit, it's up to them. And so they can easily collaborate on the code thanks to that. She also updates the backup components so that it backs up whatever is on this Git server, and she can have the full state of the code as well as the history of the commits.
Yeah, now she has a team that's really good because like the velocity and the feature she can deliver just increase very exponentially. So that's really good. But on the other hand, she doesn't have any tool right now. We are still in this mode. So like every developers and so on, to put something on production, just have to build everything on their own laptops, run manual script that they probably did to start implementing on their laptop and so on, even if it's not shared right now, and deploy on production. And because of that, like a lot of issues happen. Like sometimes somebody forgot to update like a configuration parameter somewhere, a database script, or this kind of stuff. So she decided to reinforce the delivery process. So, and to put in place like a CI/CD pipeline, continuous integration, and continuous delivery pipeline. We won't talk about tool, but it could be Jenkins, Bamboo, or whatever. Like as you probably know on all your projects. And the main idea for that is to create different environments and to be able to promulgate like some build from one environment to another and to run automated tests on each environment. So at this stage, like each developer will be able to deploy on the dev environment to run automatic tests on it. And if everything is good, yeah, it's good, and it can be moved to the next environment where we'll run more tests and so on. And for that, she decided to hire DevOps because it was a bit time-consuming and she was a bit scared to jump on that. And the number of servers will have to increase because previously we've got like only servers for the production environment. Now we have multiple environments to maintain, so it becomes a mess. And she doesn't want her velocity to be reduced and time to market to be reduced because she tried to build this new capability, so she decided to hire DevOps. And guess what? It was not so complicated to do. The DevOps do it like quite quickly and so on, and everything was good. And at the same time, Lisa just succeeded to put in place like something really important in each company, like something, a test culture where everything is driven by test and so on. So now, if we've got some issues, we will create more tests to be sure the issue won't happen again. But ideally, the test should be created before. Are we fighting together? Yes, we are. It's a good one. Okay, so DevOps was in place. He did finish to do the CI/CD pipeline. And the next step was to be, okay, it's really boring to take care about all these servers at the same time. I really need some tooling around that to be able to know whichever are going well, which the one are not going well, and so on. So he decided to put in place like a monitoring system. So he could use as services, on-premise tools and so on, Neuralink, Datadog, or this kind of stuff. But at least the main goal was to have an overview of the system, how they are used, and in case of crash, to be notified if there is some issues. And on top of that, Lisa wanted to have like some dashboards to be able to display in the open space. If something goes wrong, like everybody will know it directly, visually, seeing the screen, or maybe if they are not working during this time, by phone or by email with an alerting system.
Yeah, so that's really good. These new dashboards and alerting solutions are very helpful, and they allow Lisa to reduce her mean time to repair. But at some point, someday, an alert gets raised, 500 error received from the front end, and she starts to investigate it. And she realizes that it's actually very painful to investigate because she has to SSH into each of these instances. She's not sure if the issue comes from the web app, the reverse proxy that has some misconfiguration somewhere, or the database that's unresponsive for some reason. So she starts to look into all of those logs. She's not sure either that maybe these logs have been rotated already, because ever since slide 4, she put in place a log rotation. And she cannot reconcile logs from requests that go through the reverse proxy, the web apps, and the database. So what she does is setting up some kind of centralized logging solution to be able to reconcile all the logs from all the instances, and thanks to correlation IDs that she sets up in all of those requests, she can see one transaction going through all of those components across the entire system. And it makes investigation much, much easier. And as this project keeps being successful and users keep being in demand for new services, Lisa realizes she wants to add different kind of products, different kind of services to this previous project. So she hears, for instance, or she knows about big data. She wants to exploit all the data she has about the users, what they do on her application, and to be able to profile them, to produce some statistics, and to offer them services that are more relevant to what they're actually after. And for each of these projects, this means that she builds new environments. She needs new underlying infrastructure, new servers. And for all of the servers, there's 3 environments: dev, pre-prod, prod. There might be UAT, staging, QA. Usually, there's no shortage of idea for new environments. And in the end, it makes a lot of servers.
Yeah. So now she got a lot of servers to manage. So it was exactly what we wanted to demonstrate during this presentation. We did Smart very simply with only like just a landing page on a very small database and so on. And because of the success requirements and so on, now we've got a spaghetti plate of servers to manage. And yeah, which is not bad, because like it's thanks to the success she needed to get this way and so on. But the next steps should be like maybe there is something better we can do in this infrastructure. And by digging a bit more, Lisa just was looking about the dashboarding, monitoring, and so on, and she figured out that like some servers are using like a lot of their resources, like CPU and RAM, but most of them are doing almost nothing, like the reverse proxy and so on. It's a bit waste of resources over there, because like the CPU is quite low, not very low, but quite low, and so on. So she thinks that maybe there is something better she can improve around that. And because she's reading the news and going to conferences like we are today, she obviously heard about microservices. And in the microservice world, like even if she's not running microservices at this stage, and she probably doesn't want to move to this area at least soon, something related to that, it's everybody is talking about containers and so on. So maybe she thinks that she can use containers to solve and to rationalize a bit her infrastructure. On the other hand, she remembered that in the past, when everything was on the same server, she got some issues, and the file system that was full and so on generated like big issues. She's a bit scared about that, and she doesn't want to reproduce the same kind of error.
So the more she looks into containers and the more she experiments with them, the more she's convinced that it's actually a good idea to address most of her issues, and one of them being the densification. These containers, as far as she understands, will help her optimize her resources. They will help her add isolation. Whatever happens in one container stays in that container. Whatever resources have been allocated to one container won't be overused, so the container will only use the resources that have been allocated to it. Whatever their technologies, containers are platform agnostic, so whether it's to deploy on an on-premise cluster or on the cloud, on whatever cloud provider, it will be exactly the same image running, the same container will be able to run. They are immutable, so it's very easy to destroy one and build another one. It can ease up very easily the deployments. And one container embeds all of the dependencies, the runtime dependencies, so that makes dependency management much easier. And it also allows her to rationalize and standardize her application portfolio. So the more she looks into it, the more she knows that she feels like this is really going to be something useful for her. But she also starts to realize that there's a missing piece of infrastructure between her servers and her containers, and that would be the container orchestration. Because she doesn't want to SSH into each of her nodes, each of her servers, to start a container, make sure whatever server has enough resources to run a new container, monitor the state or the health of each container, and if it's unhealthy, destroy it and run another one somewhere else. And that's where container orchestration comes into the picture. So basically, Kubernetes, Swarm, or Rancher would be the tool to do that. So at the bottom, you'd have the server layer on the bottom of the infrastructure. On top of that, you would add the container orchestration, which will be able to fetch images from the registry. These images have previously been built by the CI/CD pipeline, and the orchestration will deploy them wherever there is some resources available. And at the end of the day, the picture we had before with all environments will be composed thanks to this container orchestration.
And so if you remember like 2 slides ago, where I was talking about spaghetti plates, now it's more like a kind of lasagna. Like we have like an infrastructure with like several layers, with an orchestrator, with like network layers on top of that, containers, application within the containers, and so on. So yeah, it's something a bit different. And because it's something a bit different, like the role of the ops and the dev will be a bit different too. So previously, the ops was just able to set up some servers and so on. Now the role of the ops will be to provide to the devs a way for them to have to be able to get by themselves the kind of resources that they will need. Like so, previously where we need to install on server and prepare it and so on. Now the main idea is to, if I want to have a database, I just configure somewhere and I get my database dynamically and so on. So the role of the ops will be to create a kind of infrastructure abstraction. That's it, to speed up the delivery time on delivery procedures. And because of that, the ops are not only operators right now. They need to do some coding too. So it's infrastructure code, obviously, but it's still code. So because it's still code, they need to have automatic tests around that. They need to have like software to apply software craftsmanship procedures as developers and so on. Maybe like post-commit review, code review, as we saw this morning, and so on. But they are still coding. So in a way, the ops become a bit dev. And on the other end, the dev now just implement, their role is not only to implement like Node.js class or Scala class and so on. They have to handle the infrastructure a bit at the same time now. So they need to understand what is a load balancer, what is resilience, like because of the orchestrator, my container could be shut down and respawn somewhere else and so on. So there is some principle to figure out over there. So they need to understand some basics of the ops. So in a way, thanks to that, or because of that, the role of the dev will to become a bit ops, as we can say. So the boundaries between dev and ops start to be a bit blurry. And this is the start of what we are calling right now DevOps, DevSecOps, or this kind of stuff. And because everybody is using the orchestrator, and they need to play with that, so dev and ops and so on, we have to keep in mind there is a very strong paradigm shift in this. So previously, everything was on one server, so it was really easy to take care about this server, to know when it was running and so on. Even if it was several servers, we know where it is and we can connect directly and so on. So there was like a kind of physical isolation, and we know where things did happen and so on. Like for development, you probably know it's on this cloud and so on. For production, on another VLAN, probably in another part of the cloud and so on. But it was quite easy for developers to figure out where the things are running. Now, we've got a big cluster running like many things at the same time, with like security and network layers, like to do isolation in between. But we are shifting from a physical isolation to a more logical isolation. And it's not so easy for developers to figure out that their application is still running somewhere, but it will run like somewhere in a cluster between node 1 and 200 maybe. And there is like a load balancer somewhere, but we can't directly access to it, or it's not so, it's not the good way to do it, and so on. So there is a bit something a bit different to handle it.
Yeah. So, what was when Lisa was originally looking for tech versatile people to work? Then she's now looking basically for Jedis who master lots of different skill sets. So they need to be fluent in software-defined networks, distributed storage, cloud, automation. They now start to write some code and probably some Golang because it's a more usual one in DevOps. So they need to learn about this one. They need to learn about containers, how they work under the hood, the container orchestrators. So it's a lot of new skills to ramp up on. And what started as an infrastructure work, it's starting to take a completely different dimension, and it's now becoming an organizational project. So how can she adapt her teams who were used to more legacy infrastructure operations? How does she make them fit to this new container dimension? How to prepare for this transition? Should she hire new people who are aware of these technologies? Should she train the existing people? How so? Should she outsource because she doesn't know how to do? And if she does outsource, how to re-own the knowledge eventually? So this project, which was initially completely technical, now takes organizational shift, and that's something that she needs to acknowledge for before actually adopting these new technologies.
And this is exactly what Gartner called bimodal IT. If we come back to Lisa's journeys, she's got like on her side her legacy systems with the production running and so on. And on the other side, the new digital way to do it, new digital factory with the Kubernetes orchestrator and so on, with a better speed to value, time to market, and so on. So the next step could be like, yeah, I still need to maintain those two systems, so it's a bit complicated. So it could be good if I can migrate my legacy to the new digital way, obviously. And for that, there is no silver bullet. Like you can't really say a priori if it could work or not. So for that, Lisa has to analyze each application and to see the impact. What are the impact of this migration? So in some cases it could work, but in some other it can't work. So there is no magics over there. Maybe it will be better for her to keep like her previous legacy systems on the side for a while, even if you don't recommend that. And she will need to deal with that a bit even if she succeeds to avoid that, it's really good. But she will probably need to take care about this, what we are calling like two-speed ITs and so on for a while.
So to wrap up, do not use a mask to drive an alien. So obviously, like architecture, like Netflix architecture, was not built in one day. So start simple, start to address whatever needs you have at the moment, and see how you can evolve over time. When you adopt new technologies, new infrastructure, then it means having new skill sets. So make sure you plan for that, how to train, how to support the teams towards this transition. And finally, this new abstraction layer on top of infrastructure have direct impacts on the way we must develop applications. So if there are ways to develop applications so that they are cloud ready, even though you don't deploy them on some Kubernetes cluster or on the cloud. There are ways like 12-factor application, the manifest that was done by Heroku. Those are the simple rules to apply, and even if it's not necessary at some point, it cannot do any harm to do it right away and to be ready for some transition later on. And thank you. Thank you for
thank you very much. We were very proud to talk in this conference. We really like conferences. And personally, I really like to talk here. And the second thing is because it's the end of November, I can get rid of that soon. So I'm very happy with that. Thank you very much.